Naesco.
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 NASCO.
NASCO. NASCO.
Naesco.
NASCO.
Hello, my name is Timothy Unruh, and I am the Executive Director of the National Association of Energy Service Companies. Welcome to our webinar today. Before we get going on the webinar, I want to remind you of a few events. Not first, but foremost is the NAESCO annual meeting, Renovate, Retrofit, Reduce. This event is the premier ESCO event of the year, and if you are in the ESCO business, you should be present. It will be at the Orlando Hilton, November 7 through 9. We have some great speakers lined up about the K-12 funding from DOE, election results for efficiency, as well as a couple of technical sessions with speakers from DOE and a national lab. Please go to the NAESCO website to find more information. The nearer events are our two regional meetings. Next week in Chicago, covering our upper Midwest states, and on October 6th in New York City, covering Northeast states. Again, go to our website for more information. That's all for now. Let's go on to the webinar.
April, the show is yours.
Awesome. Thank you so much, Tim. I am going to share my screen now. Okay, everyone should be able to see my screen. I appreciate everyone joining us today. Today we're going to talk about increasing our accuracy and payback when we're looking at duct leakage and auditing your building. With me today is John Harrington, who is Director of Application Engineering at Aeroseal. So first off, I like to always start off webinars to talk about why we care about duct leakage, right? A lot of times when you're going in to start the audits for your customers, you're looking at HVAC systems and you're looking at the age of the air handlers. You're looking at the control systems. You're looking up at the lights or thinking about water conservation. But why would you ever care about the duct work, right? And so there's a couple things that I always like to point out. The first thing is that air ducts leak, right? There's been lots of studies about this, two on either coast come to mind, one from Florida and one in California, that said that light commercial duct work that we look at all the time in your projects is typically the most leaky, right? A lot of times we see duct leakage of 30% or more. ASHRAE tells us that 75% of ducts leak 10 to 25%. And there was even a study done by the Berkeley lab that says even newly installed systems, so brand new systems, experience up to 30% of leakage. So no matter what age of the buildings we're looking at, no matter where they are in the country, duct leakage is a common problem. As a matter of fact, there was a study done by the Building Commissioning Agency, and they looked at everything in a building to figure out what the top building faults are and how much money is lost each year due to those faults. So a lot of these things that you see on these lists are things that you see every single time you're auditing a building, right? You see controls issues. You see the lights being left on when the building is unoccupied, improper refrigerant charges, dampers not working, all of these things that you would expect to find in a building. But what everyone's always shocked to see is that $2.9 billion is lost every year just due to duct leakage. And that's actually at the very top of the list. So it really matters, and it's really something that we should look for every time we're doing an audit for your project. So I'm going to turn it over to Tim. We have a couple polling questions for you.
Thanks, April. Here we go. So you should see the first question. Have you used duct sealing as an energy conservation measure? And the second question is actually out there as well. How many are familiar with duct leakage audit methods? All right. 5, 4, 3, 2, 1. Poll is ended. And the results are shared.
All right. So about a third of you have used duct sealing as an ECM. So we have a lot of ways to go. So this is why we do this. We like to educate everyone on duct leakage and why it's a problem. Some people are familiar with our audit, but a lot of people are not. So hopefully by the end of this, you get more familiar and we get to educate you on how we're improving those audit methods, and we can determine duct leakage without being so intrusive. So thank you, Tim.
You bet.
Close that out.
Oh, as soon as I can find my mouse. There we go.
Awesome. So today we're just going to talk about basic duct leakage auditing. So what ASHRAE says is best practice, what we've been doing when we've come out and look at your projects, and then our new audit method, intelligent leak detection, right? So we have really been striving to improve our processes and make it easier for you to utilize us in your projects and make everything that we do more accurate. And so intelligent leak detection does that, and we're going to talk about that. And then also we're going to talk about some additional technologies that help us improve our results for you. So first up is the basic duct leakage audit, which you look at all of this, right? And it's not very basic. The ASHRAE method is actually very cumbersome. And you think about when you go out and audit the buildings, and we're there with you, what you would have to do to make this ASHRAE method work. You would have to shut down the air handlers. We would have to block off all the vents and isolate those ducts. And then you're connecting the fan and pressurizing the duct. Does this sound familiar? This is exactly what we do when we install Aeroseal, right? But it's very time consuming. And then you do a manometer and you do the test. And this is exactly, like I said, what we do when we're actually fixing duct leakage problems. But as you can imagine, when we are going through and auditing a building with you guys, and you're looking at all of these other measures, and we're trying to get through buildings quickly, and we have limited information, it's really hard to do something this intrusive, right? Your customers do not want us shutting down air handlers. They do not need us in there for 8 hours just to look at a section of duct and get everything as accurate as we need. So while the ASHRAE method is very accurate, it's also not very easy to do when we are looking at a lot of these energy savings performance contracts projects. So what we tried to do was really, and I think my next slide talks, so again, problems with this is intrusive, right? We're getting in the way of everyday business. We're taking a lot of time and it's costly, right? There's a lot of materials you need. You have to block, who pays for that? It's just not easy. And what we want is every time that you utilize and try to utilize us or try to fix duct sealing, right? Or any duct leakage problems in a project, we want it to be like the easy button, right? As easy as possible, but we also want to make it as accurate as possible. So when we were thinking about how we can, set us up the same way that you do business, we came up with a visual duct leakage audit, which, we need some beginning, you give us some information, we get the drawings and the mechanical schedules, and that's really important. And that's still very important when we go out and we look at the buildings, because, you guys have all done tons of projects and you understand that because air handler 4 is listed on the mechanical schedule, it doesn't mean air handler 4 is still active in the building, right? So that visual audit is still an important piece of what we do. What we were also doing is we were coming in and we had assigned points to certain types of duct systems based on leakage amounts that we had seen in the past. So if it was a dual duct system, we assigned certain points. If it was a VAV, there was points associated. And from that, we assigned leakage amounts. So this helped solve one of our problems, right? It was easy and less intrusive. So we were able to come in and visually assess, pop a few ceiling tiles, look through and kind of go through this checklist. What it didn't do was really provide that accuracy that we were looking for and that you as our customer was looking for. And so that was causing some issues, right? You guys were discounting our savings. We were guaranteeing our savings, but there were times where, we may have to go back in and do additional work, or we were greatly underestimating the amount of leakage there, which is leaving money on the table for both of us, right? And so what we were really trying to fix is making sure that while we had a really easy way to not be disruptive in a building, but making sure that we had really accurate measured numbers. And I would be willing to bet that the majority of people on this call are engineers, right? And there's nothing more than you guys like are actual measured numbers, right? That we can prove out later. And so that's what we've really been trying to do. So again, the problems with the visual audit, there were things hidden, big holes, disconnects in duct work that we weren't able to always see. Also, it was inconsistent. There was no foolproof way with a visual audit to ensure that there's no hidden problems or things that, every building is different. So while we could use the law of averages and come up with that percentage, it didn't always correlate to what we were doing. And a lot of times we were being very conservative. So we've come up with a new way to audit the buildings. Like I said, we're still doing that visual audit because, just like I said, we have to make sure those air handling units are still there. We have to look at the condition of the duct. We have to make sure the VAV boxes are where they are supposed to be. But this new method actually allows us to measure leakage ahead of time and give you guys those accurate results that you're looking for. So I am going to turn it over to John Harrington, and he's going to tell you more about our intelligent leak detection. And I can say without a doubt, John is the expert in this because along with Dr. Mark Madera, who invented the Aeroseal technology, John Harrington helped invent this intelligent leak detection as well. So he really is our expert. So John, I think you're on mute right now. If you want to unmute yourself, and there we go. Awesome, thanks.
Perfect. Thank you, April. Yeah, like April said, so this system is kind of the best of both worlds for us, right? We get an accurate leakage measurement, but it's very minimally invasive. So we know how it is. We do a lot of audits. We want to run through a building, and we want the flexibility to go to a place where we test where it doesn't interrupt people. And this has really worked out well. So if you look at the next slide, we'll run you through how we actually do the test. So the step one, and we're going to get into the weeds with the kit and everything, but just big picture, step one, what our auditing team does is we're going to pick out 1 to 3 sections of ductwork that's representative sample of the duct. If we have a section that's a brand new addition or newer addition, we're going to consider that a separate section where we're going to get a representative sample. And we'll go through and actually measure the CFM coming out of each diffuser in this section of duct that we've selected. Okay, and the next step, after we measure the air, we know how much air is coming out of the test or the section we want to test. We actually set data loggers in the diffusers in 2 separate locations, and we're measuring for a baseline concentration of CO2 in parts per million. That's going to usually be between 450, 500 parts per million. So with that information, what we do, we'll show you the calculation. So we know how much air is coming out of the diffuser about, right? What we do next is we calculate the amount of CO2 we need to inject into that ductwork at that point to raise the parts per million of CO2 by 1,000 parts per million. So that first step, and I'll show you how that all comes together. So if we go to the next slide here. Okay, I'm going to back up a little bit. You notice he says, so one of the most important parts for us is to be accurate. So we're not just taking a flow hood and measuring the air that's making it out of the diffusers. We're using a power assisted flow hood. And for those of you who don't know, it takes the interference of the flow hood out of the equation. So, we're pulling air through that flow hood with a fan, and we're measuring the air. And we know if the pressure in that flow hood is 0 to the atmosphere, everything coming into that hood is leaving the flow hood. If that pressure is a little bit positive, that means we're not pulling all the air that's entering the flow hood. If we're negative, it means we're pulling more air. So it's just a very accurate way to make sure we have a really good measurement of the air that's making it out of the diffusers. So go to the next slide. Okay, so part 2. So, we measure the air that's coming out of the diffusers. We know that, right? We've calculated how much CO2 we need to inject to increase the baseline CO2 parts per million by 1,000. So if you look at this equation, we really just solve, we know the mass flow rate of CO2 we're injecting into the ductwork at this point. We know what concentration we want to get to. So we actually measure the CO2 concentration from that injection. So we'll know that from measurement. And we're simply solving for the mass airflow rate at this point. So really, you can think of this point right here as a duct traverse that's much easier to do. We don't have to drill 10, 12 holes. We have 1 hole for an injection. We know the parts per million we're injecting. We can calculate, we know how much we're increasing the concentration. From that, we can calculate the airflow at this point. And remember, we've gone through and we measured the air that actually makes it out of the diffuser. So if we know what's making it out of the diffusers and what's at this point, the delta is our leakage. So it's a very accurate, and we actually do an error analysis on each leakage test, so we know how accurate we're actually becoming, or we got. So go to the next slide. And this is a deeper dive into our CO2 trace or leak detection system. We have a tank of CO2. 5 or 10 pound tank, that's at 800 PSI. So we have a pressure deregulator to take that down to about 100 PSI. We're coming out of 800, CO2 gets very cold when you drop that pressure. So we have a heater in the system. We have a mass flow controller where we put in our set points. So we have a very accurate leakage, mass flow. We have a very accurate mass flow coming out of that system. Here's our hobo loggers. We're measuring our CO2. And here's one of the most important parts of our system. We found that the mixing of the CO2 is the most important. So when we set those hobo loggers, not in the same place, but separate places. So we want to make sure that CO2 we're injecting into that air is 100% mixed. So it doesn't matter if your leakage is 1 foot from where we're injecting or 30 feet when we're injecting, the parts per million is the same. And this kind of setup lets that CO2 go through each arm and it whips around, and it really does a good job mixing and getting that good mix and that good rise in CO2.
Yeah, so I'm going to ask a few questions at this point. We'll have time for questions, but when John and Dr. Madera first told me this, I had some questions. So I assume everyone else does too. When we talk about injecting CO2, right? The first thing I asked is it safe? And so John, can you tell us how safe it is for the amount of CO2 that we're injecting into that duct system?
Sure. So we'll, as probably a lot of the people on this call know, if we're at 500 parts per million and we're increasing by 1,000, so we're at 1,500 parts per million, and that's at the supply diffuser. So by the time that reaches the space, we're really not going above 1,000 parts per million, and the whole process takes 10 minutes, 15 minutes. So, that kind of level of CO2 parts per million in the air for that short of a time is really nothing. 100% safe. And those levels are very low.
And I think the best way I like to describe it is it's about the same amount of CO2 as 10 people walking into a room, right? Is that a pretty good analogy?
Yeah, I'd say that's about right.
Yeah, perfect. And so do we have to shut down the air handlers, and are we taking up, a lot of time when we're doing this?
Yeah, good point. Like April said, that system is running. We want it to be running because we want that duct to be under the same pressure that's operating at normally, and at the same CFM. So when it's operating under that condition, it's very accurate. If you do a duct blaster test, you're not testing that at the operating pressure most likely. You're calculating what the leakage would be at the actual operating pressure from your 25 pascals. So what we're doing here is very accurate because we're under the real operating conditions that the duct is at. And it can take anywhere from it depends how big the section is. We could do it in 20 minutes to, I'd say 20 minutes to 60 minutes is a good range for a test.
Perfect. And if we were going into, say, a middle school, how many sections would you like to test?
I think we usually have in mind 3 sections. So we'll plan for 3 sections. And if we test 2 sections and heck, they're really close to say 15% leakage, we'll probably feel comfortable with that. If we have one that's 5% leakage and one is 20, we're going to dig a little deeper, test another couple sections to make sure we have a good feeling of what the overall leakage is.
Perfect. Awesome. Thank you, John.
You're welcome.
And I think, Tim, we're ready for another audience poll.
Okay. Another poll for you. How likely are you to engage in a duct leak audit now? And what is your confidence level regarding the payback on sealing ducts? All right, we'll stop the poll in 5, 4, 3, 2, 1. Poll has ended. And there's your results, April.
Awesome. All right. So I see a lot of people are ready. Some people are still in the not sure or no way camp. The people that are still not sure, reach out to us. We would love to talk to you more about our technology and how this all works. I know it's a lot to take in quickly. We have white papers that we've written about this new methodology, and we'd love to share that with you and give you time to kind of soak it all in. Oh, I missed the last one. So, oh yeah. Everybody loves it. Oh yeah, that's an easy one. Sorry, Tim. But yeah, thank you. We appreciate that. And so I am going to, I appreciate Tim putting that back on there for us. We're really excited about advancing our technology and really making it as easy as possible for you guys to utilize duct sealing on your projects. As a company, we have a huge goal of sealing up as many residential homes, as many commercial buildings as possible to really make an impact on our environment. And you'll see, I'm sure if you follow us on LinkedIn, you can see some major things that we're doing. But I really think this intelligent leak detection is just game changing for us, and really understanding leakage in a building before we even start the duct sealing process. So we're really excited about that. I'm going to bring John back out to talk about some new tools that we've added to our bundle to just help increase efficiency and ROI. You know, these are things that our customers, you guys, have asked us, hey, have you guys ever considered doing this? Or how about doing this when you're out duct sealing? And so after some review and figuring out some things, these are a couple new technologies that we're working on. So we just wanted to introduce that to you guys today. Again, John is kind of our leading application expert. So he does a great job of explaining all this. And like I said, if you have any questions about any of that after the call, we'd love to talk to you more. So I'm going to turn it back over to John.
Awesome. Thank you, April.
Mhm.
Okay, so Shield is our new service. Well, what we do is we provide a very deep cleaning on the coil. After we do a deep cleaning, we put a coating on it that's a polyurethane with aluminum impregnated flakes. And what we're finding is that we have a really good heat transfer from that after we treated the coil with that coating. And also we found that there's some cracks. There's between the fins of the tubing and the tube. There's some gaps and cracks, and that aluminum impregnated polyurethane is actually filling those cracks. And again, just helping improve the heat transfer. Another added benefit is that when you feel the surface of that coil when you're done, it's slippery. So you don't have to go through and do a harsh coil cleaning chemical. You can go through with a hose and clean that coil off, and it really reduces O&M time as well. And like April said, this is a great fit for packaged rooftop units, maybe less than 12.5 tons or 15 tons, too small to really qualify for duct sealing. But hey, we're there. We can provide this service, and it really adds to the package, the bundle we can offer. In addition to just the coil, the casing, and outside and inside is in poor condition, we can do the refurbishment with the epoxy coated paint and new screws and new fasteners to bring that casing back up to like new. And finally, kind of along the same vein, along with those packaged rooftop units, we have, if we're in there cleaning the coating of the coil, heck, let's take a look at the motor. And, we have a offering where we're taking that old inefficient motor out, putting in a ECM motor in its place. And we're not changing the control, significantly, but if that unit goes into, a lower cooling mode or lower heating mode, lower fire or lower stage of cooling, we're going to slow that motor down a little bit to also capture that savings. One of the great advantages of this ECM is, of course, you have the energy savings, but rebates in some areas of the country are really significant. And we take a look at the rebates and we add that into the package. And I'll just add one thing. We don't bundle all these together as one price. We'll show each as a line item, so you can pick and choose. If something makes sense, you pick it. If it doesn't, you don't pick it. So we make it easy for you to pick what makes sense for you.
Awesome. Thanks, John. And yeah, I think that's a good point. So, we like to take a surgical approach when we're looking at projects. If we're looking at a school system, and the elementary school may have options for the motor upgrade, and the middle school maybe coil coating, and the high school maybe duct sealing. That surgical approach is really what we're doing. We're trying to do whatever it is to lower the payback to you for your customers, and do what's best for the buildings. So, you may see some of these on when we look at projects for you, you may see all of these, you may only see one or the other, but we really just want to let you know that these are things that we're looking at. Again, these are things that our customers asked for, and we think it fits in well with what we're offering now with the Aeroseal. So now we're going to open it up for question and answers.
So April, before we get into some questions, we've got actually 4 really good questions sitting out in our queue, but I wanted just to get some more information about the method you're using and what's happening. So kind of rewind back.
Okay.
John mentioned that the Aeroseal process of sealing ducts was appropriate for certain sizes of units. Can you expand on that, John, and tell us what is appropriate and what is not?
Sure, and certainly rates are huge. Rates and hours are a huge factor too. But I mean, generally, if we have a fractional horsepower motor, it's not going to be a project in most cases. We get excited at 5 horsepower and above.
Okay.
There are exceptions. I mean, if you're in California and maybe you have a 3 horsepower and you have good hours, we'll certainly take a look at it. But generally speaking, 5 horsepower and above is a good rule of thumb. April, what do you think? Is that about sound about right?
I think
Okay.
you're exactly right. Mhm.
And then our last poll question was probably worded poorly. What we wanted to have was we wanted to ask about how confident we are in the savings that comes out of this. And as I thought about that, I wondered, is the methodology you're doing something you developed, or is it something that you're following a standard that someone else developed?
The savings is pretty black and white. So if we seal supply duct, if we have 20% supply duct leakage and we seal that, we can slow the fan down by 20% and provide the same amount of air to the space. The fan affinity laws are black and white. You slow a fan down 20%, you scale to the exponent of 2.4 or 3 in power, with changes in speed. So that's where a majority of our savings comes from. So it's pretty solid. I like our savings plans or our savings calcs. They're simple. We do have some smaller savings in outside air. If we're inducing a little bit less outside air, we have some avoided heating and cooling costs as well.
And the method you use, is it something you developed, or is it following some standard someone else developed?
Well, it was Dr. Madeira developed the calculation method at Lawrence Berkeley National Labs, and it was tested with Energy Plus models to make sure everything kind of corresponded. So it was developed in Lawrence Berkeley National Labs by Dr. Madeira, and it's been tweaked to make it maybe more convenient to use, but it's generally the same model from the beginning.
And when you do this, have you been asked to provide measurement and verification for your installations?
Yeah, we do have some third-party studies. April, I think you have some third-party studies that show the savings.
Yeah, so at the beginning, there was tech evaluations done by the Navy that we had that verified our savings calcs and all of those. So we have all of those. When we're doing our projects now, it's typically a stipulated savings model. So we all agree on the calcs. We all agree if we have this much leakage and we seal up, the leakage, then we agree on the energy savings for that. So when we seal up a section of duct, we show how much leakage is there when we start, and we show how much leakage is there when we're done, using that ASHRAE pressure test way of measuring leakage. So we're able to immediately show how much leakage is there, how much leakage we sealed, and those go directly back into the calculation. So it's very easy to prove.
So you use the pressure test, the part you talked about at the beginning of the webinar?
Yes. So that happens every time we seal a section of the duct. You get those pressure tests, and it's happening the entire time we're sealing as well. Mm-hmm.
Okay. So you do have a measured result of the impact of duct sealing that can retroactively validate that the savings should be there.
Yes, every single time we seal up any section. Mm-hmm.
And so when you've done that, how different is that to the CO2 method you did to estimate the savings up front?
Yeah, so we've this is fairly new, but we've done some testing in our lab, and our tests are plus or minus 1%. And we've got some projects in the queue where where we've done the trade. We've done, how it goes, from the time you've done the audit to the time the project happens is a delay there. So, but we have some projects coming up where we've actually done the intelligent leak detection test. And so we're going to have more data, but the testing in the lab has been very close.
Okay, that actually is really good information. That is key information right there, that you have done some tests and validated that the CO2 estimated savings are validated by post-installation tests that show the duct sealing does provide that savings. That's a great result. So one of the questions we have is asking about payback. If you assume you have a kWh rate of about 10 cents, what do you see a payback that might be reasonable to give the audience an idea of what they might expect on a project?
Yeah, and of course it varies a lot, but 10 cents is not a bad rate. So 3 to 7 years type of range is pretty typical.
And is there a way to understand how big this ECM is in cost? Is there a way, like per square foot, you might think of it or understand?
Yeah, we estimate about $1 per square foot is a good way. $1 per CFM, which translates to about $1 per square foot, right? We're becoming more efficient in the field, so I think the prices are going down, but just a good rule of thumb is about $1 per square foot.
Okay. And then a question came in on the coil, the shield coil sealing, where you're putting the coating on that adds the aluminum flakes, I think it was, to help to provide the heat transfer. How deep will that go if you've got several layers of coil? Will it get all of those very well, or does it just get the surface?
Yeah, it goes. So we've done 1-row coils and we've done 8-row coils. So when you do the deeper coil, it's a much slower process. You'll see the guys in the field, they'll just really go really slow, and they hit it at a few different angles, so they can get deep. But that's a great question. The deeper the coil, the longer it takes, so to get it really into the coil.
And this is like a paint, effectively, you're putting in. Is there a duration that it lasts, or does it wear off, or does it rub off, or?
I think our warranty is 7 years is the warranty, April. Does that sound?
That sounds right. We'll probably have to verify that.
Yeah.
The shield is newer. The duct sealing, though, we can tell you lasts for over 30 years. So we just do that one time and we're done. Yeah.
Okay. And I assume you can buy any one of these types of things that you talked about, or they sync together somehow.
Yeah, we do them all as separate line items, separate, so you could one or the other. There's quantities of scale, right? And it's our team doing the work for all the measures. So, mobilizations and things like that. If we're doing them all, there's some, the cheaper it gets, but yes.
And so since we're talking to an ESCO audience, talk about the process of how you would engage with an ESCO to do this type of work. Remember, they often have an RFP may come out of some sort, and they may have to provide a preliminary assessment, which would engage yours and other vendor services. How would they engage? What do they have to pay for? What's the time frame? How does all that work?
Yeah, so we have at the RFP stage, we ask for some data up front. We know at the RFP stage, there's some data you have and some you don't, right? So we ask for a lot, but you send us what you have and we can make assumptions for everything else, right? And so John's team, the estimators, will actually do cost and energy calculations at that point. And from there, we will send it to you and say, hey, it looks like it's, this is the payback. You give us a thumbs up, or I'm not sure. And, we can, if we get the thumbs up, it's in line with what you're looking for. And we do that all at risk. Then we'll actually come out and audit the building. The intelligent leak detection audit, the visual audit, it's all done at risk. So everything we're doing up until installation is done at risk, no cost to the ESCO at all. We really want to partner with you, with the ESCOs, to ensure that every time they have a project, they're giving us a call, and we're, one of those lists of ECMs that they use all the time. So, we will tell you if it's not a great fit up front, because, we don't want to travel out there if it's not going to work either, right? So, but we'll come out, we'll do the intelligent leak detection, we'll do that visual audit, and we'll refine all those energy calculations that we did at the preliminary stage. So the more information we get, the more accurate everything's getting, and we'll provide that back with a proposal back to the ESCO, and then we work on from there. And then when we go to actually installing, we have a team, service providers that travel around the country and do nothing but energy service contracts. So this is nothing that we have to subcontract or find somebody in the area, nothing like that. Our team has been vetted. They work on federal contracts, all of this, and so it's an easy call to make. Our lead time is usually, right now, it's about 6 weeks out before we can come out on site for installation. So.
And then, so just again, kind of think about the ESCO crowd and what they would want to know. So if I had a 5 horsepower motor, what type of kWh rate would I be looking for?
That's a good question. So, yeah, 10 cents. I think 10 cents a kilowatt hour, and a lot of it has to do with hours too, right? So I think hours is probably, I would say I'd want 10 cents a kilowatt hour, and at least like 60 hours a week of operating time. And I'm just kind of going, just kind of go off the top of my head, but somewhere in that neighborhood.
A lot of times the buildings that we're working in are going to be either a school, probably a larger school for this type size, or some sort of an office building would be common locations where I think this might occur. And if you see those buildings, they're probably going to be on a rate that might be less than 10 cents. So is there, if you don't have 10 cents, is it just not worth pursuing?
We always like to say, if you see units and they're 5 horsepower or more, and you're not sure, send it to us. We're happy to take a look, because there's a lot of times we'll say no, but we're glad we looked. It doesn't look like a good opportunity, or sometimes the hours are there, and we can make it work. So I think if it's on edge, we're happy to take a look at it, right, April?
And there's other factors, outside air percentages, we get savings from that. There's some other things that we look at as well. So where it is in the country, if you're a high cooling area or high heat area, that helps. Those are a little harder to do in milder climates, but if you're somewhere that's running a lot of cooling, then, we may be able to work. So like John said, it's easier to send us over. We can look at it quickly, run it through. And like I said, there's no cost to you to do that. And we can turn it around quickly.
And we also calculate demand charges, right? So that plays into the equation. So if we have some nice demand charges along with the rates, that helps for sure.
So I guess what I think I heard was if I have about 100,000 square foot building, I should expect a cost probably somewhere around $100,000 for the duct sleeving to occur, and I would expect savings. If it's a 3-year payback, that would be roughly $33,000. If it's a 7-year payback, maybe $15,000. Maybe a little less than 15,000. If my rate were, instead of 10 cents, it was 5 cents, I would just expect that those savings would be cut in half. Yeah. But that would mean I went from a 3 to 7 year payback to a 6 to 14 year payback, still pretty well within the range of a project. Yeah. Okay. A question came in about the cleanliness of the duct and testing and sealing. Tell us what you need there.
Yeah, so as long as there's not more than an eighth of an inch of dirt or debris, we can seal that duct. So if a duct does need cleaned, a lot of times it's the exhaust duct always needs cleaned. We'll look at that. That's part of the visual inspection. We'll tell you if it needs cleaned or not, and we can offer services for that. Some of our customers and some of the ESCO's customers ask for duct cleaning and the bundle that they're asking their customers for, or their ESCO for. And so we do that as a service as well, just because, you know, it aligns with what we're doing. So we can always get pricing for duct cleaning. We don't always have to clean the ducts though. So at 1/8 of an inch, it's kind of it must be done or not. And then John can talk about whether we have to do that to do the intelligent leak detection.
Okay. And a question comes in about healthcare, where they're concerned about downtime. When you do healthcare facilities, they don't like to shut anything down ever. A lot of facilities are like that. But how do you handle that downtime or minimizing downtime when you're doing this project?
Yeah, healthcare is one of our greatest opportunities. And, you know, there are a lot of areas in a hospital, office spaces, things like that, where we can easily, you know, get to shut down the air handler for a period of time. We work a lot of times after hours, on weekends, during, you know, other shutdown periods. However, we do, and there's case studies on our website where we've done operating theaters or we've done patient rooms where, you know, sections. And what we do there is we just work really closely with the facilities manager to understand, you know, there may be a couple hours where operating room 1 may have to go down, and we can isolate that duct section so that we ensure that, you know, we can only do that section of the duct and we can do it quickly and it's only down for a certain period and then we do the rest, right? So it gets a little more labor intensive when we're doing that, but we try to have as small of impact as possible. Yeah. John, do you have anything to add to that?
No, that sounds about right. Yeah, you don't know when we started a project in the second or third shift and we're done, you don't know we're there. We put everything back and it's like we weren't even there. So that's, you know, how we try to operate.
Yeah.
And a question came in about UV. I think that probably is related to the coating of the coils. Does it enhance or detract UV on the coils? No impact?
Yeah, that's a good question. I mean, I can't see of any way it would degrade that coating, but that's something we can look into. I haven't had that question. I had that question before. You know, the coating, I would say it would enhance the performance of the UV because we have a very slick coating. We don't have all kind of cracks and crevices where, you know, we can have a growth of pathogens we don't want. So I would think it would enhance it, but that's a great question. You know, we should, I can't imagine it degrading the integrity of the polyurethane, but we could certainly take a closer look at that.
And a question came in that says, if I understand correctly, you only test a few duct branches, thus sampling. What is your methodology for sizing the quantity of samples and selecting the location of the samples? So is it sampling? And if it is, how do you do those?
Sure. Well, I mean, what we like to do is we'll pick we'll look at the plans and say, hey, these sections look like they're a good representative sample from the plans. You know, you never know, but we might send 5 different options to look from. We'll send that to the client, to the ESCO, and they'll work with the client and say, what do you think of these areas to test? And so if everyone signs off, like these areas look like they're good to test as far as you know, not disrupting anyone in the day-to-day operations. When we actually get on site, you know, sometimes we need to go to a plan B, but we physically look at that ductwork. Is the construction consistent for the 3 sections we're going to test? If it's consistent with the rest of the building, then we're going to say, hey, we feel this is a good sample of ductwork. Now, how big? We're limited, you know, I think we're limited to about 4 standard cubic feet per minute from our discharge from our intelligent leak detecting machine. So, you know, that limits us to maybe, I think, 5,000 or 6,000 CFM of duct section. So, you know, we start getting above 5,000 or 6,000 CFM of air in that section of duct, then we really can't do it. So, you know, that kind of determines the sections we're going to test also. If that makes sense.
And if we see in the plans that there's been like a major renovation, duct has been installed in different times, then we will sample those separately.
Well, we have answered all of our questions. So April or John, do you have anything to say in closing?
No, we appreciate everyone's time. Reach out to us if you have any other questions, have any projects that you would like us to look at. We're here. Like I said, we want to make this as easy as possible for you. So we look forward to hearing from everyone. We really appreciate NAESCO's support in providing this webinar and letting us get, you know, the information out there about intelligent leak detection and how important it is to look at duct leakage.
Well, thank you, April, and thanks, audience. Great to have everybody here today, and have a great afternoon.
Awesome.
Thank you.
Stay cool.
Mhm.